That's when you guys ask me questions, well, that's how I learn some more. So I not only know what I know, but I end up knowing what you know. So this is one device.
Okay. Have you experimented?
Working from photograph there, the pancake type deal, is that what you want to ask about?
Yes.
And you want some general statements on it as to why it works and how it works and that sort of thing? Okay, whenever you take a, take a coil and instead of being a normal, let me put this down before I touch it again. In a coil system, like in a normal Tesla coil, they're normally high and skinny and that sort of thing. That's the wrong way to go if you're wanting amps and stuff, because the length is volts and the diameter is amps. So if you get the right combination of this versus this, then you've got plenty of amps and plenty of volts. So, and also, depending on how you tap onto the coil will determine whether you get amperage. But there's the same amount of amps there as there are volts, because in the magnetic system that's driving it, it has to be equal and opposite. That's your Lenz's law, you know, it's equal and opposite. So that means that your one of those is your magnetic or your field, and the other is the electrical field. And the magnetic field is amps.
Okay. And what about bifilar coil?
On the
A bifilar coil.
Bifilar coil.
how does it what's the ratio? Okay, whenever the center of the pancake coil is certain size, and the outer ring is a certain size, and then the L1 coil is maybe a couple of turns on the outside of it. So the ratio of the diameter of the inside versus the outside turn on it is the improvement or the advantage that you gain by doing it that way. So in the one that's in the picture in the book there, the ratio is 1 to 5. So not only do you get the L1 and L2 gain, you get 5 times that. So that's the advantage of pancake coil.
But they are one wire or B wire?
The outside, well, the L1 wire should be an even division of whatever the length of the L2 is. That way they're able to talk to each other. The frequency, if you worry about the frequency, don't worry about that. Just build the thing so it looks nice, and make an even division, even multiple or even division of the lengths of the wires that you want to talk to each other, and they'll be talking to each other.
What's the ratio? What's
The ratio in the case of the one that's in the book is 1 to 5. So it's 5 times what, plus the fact that it's a normal Tesla coil. Your normal gain times 5.
Do you ever do quarter of the wavelength like Tesla did?
And what?
Do you ever do quarter of the wavelength like Tesla did for his coils?
Well, they will be able to talk to each other, and you can calculate the wavelength because you take the speed of light and divide that by a certain factor, and that will tell you how long the wire will be for a certain frequency. What I did on that particular one, I used about 200 megahertz, which meant the wire was going to be about 18 to 20 feet long. I think it was 18 something. And then once I had the main frequency set up, then I made the other coil. So as long as it's a even division or a multiple of, you know, whichever way you go, they're going to talk to each other, and that's all you need. Okay. There are a lot of different things. This thing's a little bit heavy, and I see it's got a lot of sawdust on it because it was sitting, let's see which way to turn it. We don't want this to fall out. Can you see it okay?
Yes.
Okay, you notice that this main coil there has the center part of it cut out, and the two cut things are brought over as your ground deal. Okay, and the ends, the electrons are spinning one direction, going this way, and spinning the other direction going that way. So you've got electricity and you've got amps. And when they come together, then it continues on. So you've put the two together, and you've got more amps than you know what to do with, and more electricity you know what to do with. So it has to be cut back. This is a diode bridge here. You go in and out of these inverter systems. Since this thing has to run on alternating current at 120 volts, in order to get to that from the battery, I had to use an inverter, and people make fun of me because I use Radio Shack inverters, but in this case, the high voltage thing there has to run off of 120 volts at 60 cycles. So that's how I get to there. And I've got a rheostat here where I can raise and lower the input so that over here it comes out to the correct amount that I want. And on the process, this is 8,000, well, it's 2,000 volts each. So it ends up being like 8,000 volts, so I have to be careful not to get beyond that. And they're 8 microfarads each. Now I have some 50 farad capacitors, which are newly available on the market, and they actually go up to well beyond that. But the trouble, the way they manufacture them today, they are down in the voltage level, which is too low. So by paralleling them and other ways, you get up in the voltage range that you want.
So you use a super capacitor?
Yeah,
Ultra capacitor?
I have several of them, and I use them in some of my larger units. And I mean, tell you, one like this, if you stick a screwdriver in there while it's running, about half the screwdriver evaporates. I know, but it makes a noise. It'll unnerve you and the whole neighborhood. You'll have everybody in the neighborhood for blocks around running outside to see where the explosion was. And you'll end up with a screwdriver with a handle with just a little bit of metal left on it.
Why do you have the cap, the white cap on one side of those
What is he asking?
secondaries?
Well, the capacitor on your LCD.
Why do I have what? Why that one there?
Because it seems symmetrical.
Well, when I got to that point, it was out of tune. So I had to do some tuning on it to keep it going on. And the reason for this is it's also a tuning mechanism, but it turned out when I got built, it didn't really need very much tuning. So I never really had much. This is your old slide radio thing, or your tuning, like tuning antennas. And the L1 is the red that's on the inside there. And this is your L2 system, but it's a double one set up so that the amps and volts and everything are in there in a proper order. And this one I built in 1994. So, and there are over 200 of these different devices in existence right now, and the more recent ones are subject to business deals and things, so I can't show you them. But the idea is to try to fix it so that you can get the idea and you can build your own. And actuality, I had something in my briefcase that I wanted to give you because everyone wants schematics. And this particular one was so simple that it was ridiculous. And what I'll have to do is just give it to Bruce here and let him post it. Because I actually ran out of ink printing the darn things up to bring over to you. And then I apparently walked off and left them. And I had a lot of help this morning in getting here, and that's why I was late. But anyhow, how are we doing? We have how many minutes?
Can I ask a question?
We have
60 minutes?
another hour? Okay, well, we can still do it.